sources would have been, and this is what the CMB signal would have looked like for 1 degree Kelvin. Of course, they published this in a Soviet journal. It takes a long time to get translated. Nobody reads it. What's really interesting is this. They say, measurements reported in Ohm in 1961 give a temperature of 2.3 Kelvin, which coincides with theoretically computed atmospheric noise. Additional measurements in this region, preferably on an artificial or satellite, will assist to find the solution to the problem of the correctness of Gamow theory. This paper from Ohm was published in 1961 from observations made at Bell Labs. Really, the temperature was 3.3 Kelvin. They probably read a translation, and the table was translated improperly. Again, this paper is completely unnoticed by everybody. Princeton to Homedale is 35 miles. That's where the telescope is that has made these observations. Moscow to Homedale is 4,600 miles. You go figure. This paper was published in the Bell Labs Systems Technical Journal. I asked Andre, I'm friends with Andre, I asked Andre, how in the world did you find this paper in the Bell Labs Systems Technical Journal behind the Iron Curtain in the 1960s? He said, oh, they translated all those journals, and we worked in this big, so I went down the hall and asked a bunch of radio astronomers if they ever heard of anything like this, or if there was a radio telescope, and they said, oh yeah, check out this journal, maybe you'll find something in there, and he found this paper in there. But this guy, Dickey, who's 35 miles away, doesn't know anything about this paper. I asked Ohm, because Ohm is still alive, I called him in New Jersey last year, and I asked him, you were doing this stuff, did you know who Bob Dickey was? He goes, oh yeah, Bob Dickey, he was a white hat, he was a great guy, he was famous for doing microwave, radiometers and all this sort of stuff. I said, why didn't you go and talk to him? He goes, oh, we just never got over there, I figured he was a busy guy. In '63, this guy Jakes, he repeats the same experiment with the same telescope and a different detector, and he finds this kind of ambient temperature of 2.5 Kelvin. These are the two numbers that were incorrectly read from the table, but if you subtract the total system temperature from the temperature observed, you get around 3 Kelvin. So it was already observed in 1960, well, July 61, it was published, this observation. This is the cosmic microwave background signal being detected. Okay, so back to that telescope. So again, the intent of these guys that were using the telescope was to measure radiation from interstellar emission in our galaxy. Again, wide areas, that's a good telescope to use. These two guys, Penzias and Wilson, who were using that Bell Labs telescope, which I said has already detected the CMB, found a source that was direction independent, and they realized after some months the source had to be instrumental and cosmic. Many of you know the story. They tried to clean out the telescope. They found a pigeon's nest in it. They cleaned the pigeons out. They cleaned the bird crap off the telescope. They sent the pigeons away. The pigeons were homing pigeons. They were back the next week. They got the telescope covered again. They taped over all the rivets and everything. They couldn't get rid of the signal no matter what they did. They didn't know what it was, what was going on. What is this noise in their instrument they cannot get rid of? So Penzias, he mentions this noise problem to a friend of his, Bernie Burke, and Burke says, oh, I heard about a talk by Jim Peebles, this cosmologist at Princeton, from my friend Ken Turner. Maybe you should call those guys. Maybe they have some idea what it is. Peebles had mentioned that there's a 10K radiation from the Big Bang that they want to detect. I mentioned that paper earlier that he and Dickey had been working on. So here's Penzias and Wilson from the telescope. He contacts Dickey, and Dickey picks up the phone, apparently in the lab, and I talked to Jim Peebles about this, and he says, yeah, he was talking on the phone in our laboratory, and he gets this call from Penzias, and he says, oh, I see, yeah, well, I think you've detected blah, 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 blah. And he's been scooped. He's been trying to make this observation himself, but a telescope only 35 miles away, which he doesn't even know about, has made the telescope. How he does not know about this telescope, again, it boggles the mind, because this ECHO project was a big project. It was on the front page of the New York Times. He certainly, I said, did this guy read the New York Times? I mean, come on, you're in New Jersey. That's the local newspaper. He said, I don't know. No, he didn't know about it. So these guys found the temperature closer to 3K. We already know that from Ohm's observations, but Ohm's observations have been completely forgotten. No one knows about them, except the Russians, of course. Not that 20 Kelvin that Zeldovich had detected, not Dickey's 10K, a little bit higher, but much closer to Alpha and Herman's original 1948 5 Kelvin. Pretty amazing. So they published 2 papers in the Astrophysical Journal on the detection. One is a theory paper by Dickey, because remember, these guys are radio astronomers. They don't know anything about the Big Bang. They don't know anything about cosmology. That's Dickey stuff. So Dickey writes the theory paper. They write an experimental paper. Submitted both these papers on May 13, 1965, but less than a week later, there are leaks. And it's on the front page of the New York Times. Signals imply a Big Bang universe. And here we have Alan Sandage, passed away last week, talking about what it all meant. Okay, so let me just mention a little bit about these Russian guys. So Novikov reminds Zeldovich that, hey, they detected, they wrote this paper saying that it was detectable. And Zeldovich scolds them. He says, well, you probably didn't include a spectrum of the paper, of the radiation in your paper. And they said, it actually had the spectrum. And then he said, he scolded us for the absence of effective propaganda of our paper. So be careful who you pick for your supervisor. If you don't effectively promote your paper, you can't win, apparently. And this is behind the Iron Curtain. What could these guys do? I mean, how much more could they promote this paper? I don't know, but that's what Zeldovich told them. Of course, these guys get the Nobel Prize in Physics. They eventually read up on the topic. They find out about Doroshkevich and Novikov's paper. They mention it in the Nobel Prize speech. And of course, they mention those very early predictions from Alpha Herman and Gamma in that speech as well. Just to kind of finish up, the dipole was probably detected in 71. I say probably. Ned Wright has a whole page talking about how the dipole and the quadrupole were measured and why he thinks Henry should get the credit for that. Probably the relic experiment, if it had kept flying and hadn't died early, would have been able to detect some other interesting aspects of the CMB that Kobe detected itself. But I just love showing pictures of this instrument. It reminds me of a Klingon battle cruiser. The Russians make really cool-looking spaceships. Oh, that was the map of the CMB from this Prognos relic spacecraft. 1990, the Kobe data comes in. They show the Planck blackbody spectrum. So before Kobe was launched, all we had were little pieces of this measured in different wavelengths, and it looked like the spectrum might not be blackbody, that it might actually be power law or something else really strange. So it was really big news when this satellite data came in 1990 and showed that it was a perfect blackbody spectrum in the CMB. In 1992, it's the first evidence of small-scale anisotropy. This was the paper. I mean, this was the picture that they published in 1992. I think this was on the cover of Physics Today, if you remember, in 1992. It was really big news. The 2D map shown at APS, and apparently got a standing ovation at the APS. How many times do you get standing ovations at the APS? I don't know. I don't think very often. And then, of course, just remember, in 1988-99, Lambda returns. We got rid of it for all those years, and it shows up back again in the data, so we can't get rid of this beast. It keeps haunting us. If Einstein was around, his head would be spinning, I guess, trying to figure out what it all means. Of course, there have been two Nobel Prizes for cosmic microwave background physics, and the second was for the Kobe mission. Mather and Smoot got that in 2006, and I was lucky enough to be there at the Nobel dinner when they got the prize, actually. Okay, so another couple other comments just for the end here. So people often ask, why didn't these other guys get a Nobel Prize? Novikov, Doroshkevich said incredible predictions, Dickey's predictions, Alpha, Herman, and Gamma, all those important predictions. But as you know, you can only share the prize between 3 people unless you're the United Nations. But I love Rich Gott's quote from his book about this, and I think you just have to read it because it's hilarious and it rings so true. So Gamo's prediction of the CMB radiation and getting its temperature right to within a factor of 2, it was 5, they guessed 5, it was 2.3, was a remarkable accomplishment, rather like predicting that a flying saucer 50 feet in width would land on the White House lawn, and then watching one 27 feet in width actually show up. One can call it the most remarkable scientific prediction ever to be verified experimentally. Another comment. Hubble gets the credit for the expansion of the universe in every single introductory astronomy textbook on the planet Earth, and he should not. He should go to the moon. And I just give you an example. Professional astronomers still make the mistake. Here's a paper posted on Astro PH 2009, Martinez and Trimble, good, knowledgeable astronomers, and they say discovery, expansion of the universe carried out by Hubble in 29 allowed for these models. That's because these guys have only read the monthly notices paper. Nobody, or very few people, I should say, there's a couple of people that have actually read the original paper in Dutch, or in French rather, and seen those numbers and realized that he made the prediction long before these guys did. A couple books I can recommend if you're interested in this topic. One is Craig's Cosmology and Controversy. This book is mostly about Big Bang cosmology versus steady-state cosmology, but he talks a lot about these issues. People's book, Finding the Big Bang, is excellent. It's a contribution from many different people working in this field. It's a really fun read. And two other books that have been published since I started writing this talk. One is Bartusiak's book, The Day We Found the Universe. Her whole book is all about how Edwin Hubble discovered these nebula outside the Milky Way and realized that the universe was not just the Milky Way galaxy. It's a fantastic book. And a book that was published last year by Harry Nussbaumer, who's at ETH in Zurich, and Vieri, who's now, I think, a postdoc at Harvard, called Discovering the Expanding Universe. And he has also read the original papers in French. And he is trying to set the record straight for that. But if you're interested, you can download slides from either of these websites, and then thank you very much.